Today, we are going to continue working with ratio tables by looking at some of the problem solving that we will see with ratio tables this year. Let's remember that a ratio compares two things and it kind of describes a pattern which can be repeated. We can write that ratio three different ways. We can write it in words using the word two with the colon or written as a fraction. When we have two ratios that are equivalent, like on our ratio tables, those are considered a proportion. In this example, the proportion is written as an equation, which we will look at later this week. Let's take a look at our warm-up today. Jesse is working on the warm-up on the problem below. He immediately eliminates answer choices A and C. Read the problem below and look at the answer choices he eliminated. What do you think Jesse noticed about A and C? So in a recipe, 3 eggs are used to make 45 cookies. Which table shows the relationship between the number of eggs used and the number of cookies made? Okay, so the table that we are looking for should have this ratio, or it should have ratios that are equivalent to 3 eggs and 45 cookies. So when he looks at table A, why do we think that he saw right away table A couldn't possibly be the answer? Okay, good. So the reason why A cannot possibly be the answer is because in table A, all of the number of cookies are exactly the same. They all say 15. Whereas if you're going to use more eggs, right? These numbers are going up. If you're going to have more eggs, you should also be making more cookies. Okay, so I think he eliminated A because the number of cookies doesn't change. Okay, looking at answer choice C, he noticed something on answer choice C. Why do you think he eliminated answer choice C? Good, so he probably noticed that in answer choice C, the number of eggs is way larger than the number of cookies. So 90 eggs to only make 6 cookies there's just no way. Like, that's not correct. In our original ratio, 3 eggs are used to make 45 cookies. So the number of cookies should be way more than the number of eggs, right? So that means that this cannot possibly be the correct table. So I think he eliminated C because the number of cookies should be more than the number of eggs. Okay. All right, so he's already got 2 answer choices eliminated, and that leaves either B or D. So if we want to figure out which of those it is the correct answer, then we need to go back to this ratio, right? So 3 eggs should make 45 cookies. Okay, so I can find a multiplier here from 3 to 45, right? That's one way I can do it. Or I can add it to my table, 3 and 45, and see if it fits the pattern. Okay, so let's look at answer choice B. If I go from 3 to 6, how would I get from 3 to 6? 3 times what? Times 2. So if we double the number of eggs, we would expect that the number of cookies should also be doubled. So is 45 times 2 going to give us 270? No, that is not correct. So if this ratio is wrong, then the whole table is wrong, and B can be eliminated. Okay? We could also figure out that 3 times 15 gives us 45, which means on the table, all of these should be times 15. So we would then just need to take any one of these and work them out to see if we got the correct answer, if we got what's here. So if I do like 15 times 6, 5 times 6 is 30, and then 6 plus 3 is 9, so we should get 90, not 270s. That's way too big. Okay? All right, so then if we look at answer choice D, we do see that 90 right there, right? And if we pick another one, for example, I can see from 6 to 12, that's twice as much. So is the number of cookies also twice as much? Yes. So I have found 2 correct ratios on here, and I've eliminated the other 3, so I'm pretty confident that D is my answer. Okay. So today we are looking at some problem solving with ratio tables. And there's 2 kind of styles of problems that we're going to see like on our STAR test and possibly on our little mini CDB, our PSDIs. So we want to be familiar and kind of understand what strategies we can use on these and how we can go about solving them. So here's our first problem. The table below shows the cost of purchasing different amounts of apples. Based on the information in the table, how much would it cost to purchase 20 pounds of apples? So our table is telling us pounds of apples and the cost. And it's showing us 3 equivalent ratios. We can get 4 pounds for $6, which is the same thing as getting 10 pounds for $15, or getting 16 pounds for $24. Okay? They're asking us, though, about 20 pounds. Is 20 pounds on the table? No, we don't see 20 anywhere on that table. Where would it go? Would it go in the first column or in the second column? Correct, it would go in the first column. So we're just going to add 20 pounds to our table. Okay, and then I'm going to use my strategies. I can look for a multiplier going across. So from 4 to 6, that multiplier isn't very clear. So I'm going to try going the other direction. So which of these numbers in this first column here can I use to make 20? Good, so we kind of have a choice, right? We could do 4 times 5, or we could do 10 times 2. It doesn't matter which one we do. So, oops, that's a highlighter. So if we do 4 times 5, if it's times 5 on the left, then we need to do times 5 on the right. So 6 times 5 would make $30. Okay? All right, another strategy that we could use here is that we could take